All right, so tonight we are covering Last Night of Me for a couple weeks. Reminder tomorrow, office hours, 6:30 to 8:30 on the YouTube live stream. Submit your questions on Slack. Um, Tonight we are going to cover a little object-oriented programming with JavaScript. We're going to start with prototypes on JavaScript, which is where the JavaScript language is kind of different from other programming languages. And then we're also going to cover the basic ideas and inheritance and all that kind of stuff. We're going to keep the party going on Free Code Camp and try and plow through all of these topics. I promise these topics tonight will not be as short as higher order functions were last night. And then after that, we can kind of decide if we want to split out and pair program on the basic algorithms, or if you guys would rather me go through some things that I was planning on doing last night. So there might be more value in pair programming. There might be more value in me just continuing to talk. If you guys aren't sick of my voice yet, I don't know what else I can do. So we're going to get started here. This is use dot notation to access the properties of an object in Free Code Camp. It is in the object-oriented programming section. And I'm going to blow this up before I forget. Should be under the JavaScript section, under object-oriented programming, and it's the second item. Everyone ready? Yep. Good to go. JavaScript and object-oriented programming. All right, so we're going to start out with accessing the properties of a project. This should seem familiar to you guys. There is a little bit of an overlap. You keep on hearing me say object-oriented programming, and we've been working with objects all week. So we're going to kind of keep that, and instead of it just being objects, we're going to make those objects oriented towards the programming that we're going to be doing. So we'll get into that in a second, but this should be pretty easy. Let's see, it wants us to print the value for the name property of the dog object. So anyone want to throw that out?
Console.log, parentheses, dog.name, and then Elon, you have two legs too. No legs.
Good. Should be nice and simple. Just a little review for everyone. On to the next one. All right, so now we're going to get a little fancy. So we've set our values to our objects. I'm sorry, the values to the keys. Oh, thank you. That should update in a second. Thank you for catching me. So we've done a couple different things in our objects, right? We've set strings to the values of our keys. We've set numbers. Now we've done arrays. Now we're going to go in and we're going to write a function inside of our object directly. So in their example, they have this thing in the duck object that says say name, and when you run say name, it's going to return some string with some more information in it. So when we go down here, it's saying that it wants a say legs function, and it wants say legs to say this dog has 4 legs. So we're going to define our key the way we always have, right? Which is say legs. And instead of just putting the value directly in here, we're going to put a function instead. So we're going to say function, and we're going to do our curly braces, and we're going to be good about indentation. And in our say legs, we are going to return this dog has, and capitalization and spaces here matter, so make sure you have this space inside your quote. and we're going to say dog dot num legs. And so what the computer's going to do is it's going to get to this point. It's going to say dog. Where is dog? Dog is up here. All right, num legs. We're using our dot notation. Go get num legs. Num legs is equal to 4. Drop 4 in here. And because that plus is on a string, we're just concatenating, right? We're just putting some information together. And then we're going to do another plus, another quote, and another space that says legs period. I'm going to pull this over just so you guys can see. So it's important to have the space here and important to have the space here. And we're going to go ahead and run that. All right, awesome. So basically what we just said here is this code that is running is our dog.sayLegs, right? So what's important is we have our curly braces right, or our parentheses right here, because otherwise what's going to happen is if we just say dog.sayLegs and we console log that, our dog.sayLegs is going to return the function. It's like, oh, you want say legs in that object? Sure, here you go. Say legs is a function, and here's all the code that's in it. They're like, no, 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 we don't want just the function. We want the function to run. And so that's when we pass in our parentheses, right? And the parentheses tell the JavaScript, all right, let's go ahead and run that function. So now we have this dog has 4 legs. We passed it. We're good to go. There have been several times that I have written out a whole function and go, why is it telling me it's a function? Or even better, object object. Well, thanks, object object. I'd like the value of it. So that's when the parentheses are important. All right, so what we did before is very similar to this, right? I'm going to just add some indentation so it's easier to read, some new lines. This is exactly what we had. This dog has 4 legs, but basically what they're saying here is instead of saying dog, it's generally not best practice to reference the name of the object that it's in. And that's because this isn't necessarily reusable. So in order to make it a little bit more reusable, we can replace this dog part here with a special keyword called this. And this is a reserved word in the JavaScript programming language. And as of ES6 has become a lot more interesting. That will be covered a little bit more when we get into React land. But what we are saying is instead of referencing dog, what we're saying is just this is going to be whatever object that we're working in. So this is going to go, oh, this, we're in the dog object. Let's look at that dog object and find num legs. So let's run it.
I'm stuck on the last one.
Sure. Space. Space after the has in the quote. Right? Because look at what's coming out. This dog, and then dog is num legs instead of just legs. And then if we look down here, we're really close, but we're missing that space in legs. And it's super helpful to console log out these things. So if you look at the output and you notice that the output is, if we, console log what we're expecting to come out here, and we look at the output and we go, that doesn't look right when we're reading the sentence, that's when it's super helpful to go back and see what's in the quotes versus what's outside of the quotes. We add our space in. Now that looks better. So sometimes the answer isn't actually in your code. Sometimes it's easier to find the answer running and executing your code. All right, on to the next one. Or not. Now on to the next one. Okay, so let's get a little bit more object oriented. So what we're going to do is we're going to create a constructor. And a constructor is just a function that we put some values in, and we assign those values right into that function. So in this example, we have function bird. We capitalize the B, which is not what we are used to doing with function names. And the reason why we capitalize it is because it's convention to capitalize the first letter of a constructor. Okay? And the bird function that we're creating here, or almost we're getting closer to objects, has a name, a color, and num legs. So what we're going to do is we're going to do a function called dog. We're going to do our opening and closing parentheses and our curly braces. And we're going to say this dot name is equal to, we can call the dog whatever we would like. And this dot color is equal to whatever color we would like. And this dot num legs, and that one is going to be a number. And we're going to run it, and we got it. So what we're going to notice here is like, great, we just created this function, but we're not doing anything with it. We told the computer, all right, here's this thing called dog, and it has these variables inside of it, but we didn't do anything with it yet. So let's go on to the next challenge. And now we have our dog, just like we had before. They changed the names, that's okay. But now we need to create that dog. We told the computer, hey, there's this function, but because we never actually used the dog, the computer was just like, I'm going to ignore this. So what we do is we come down here, and they would like a hound to be created using the dog. So what we're going to do is we're going to say, I'm going to play it safe and use var here. Var hound is equal to, and now just like this was a special reserved keyword, like var is a special reserved keyword, we're also going to use a new keyword here called new. And what we're going to do is we're going to do a new dog. And we're going to run it, and we got it. So great, now we created it. Let's do a little bit more with it. So what we can do is we can assign properties or variables inside of that instance of the bird. So we're going to come down here. We can also pass in parameters for when we create it using the constructor, and then set what the incoming data is with those parameters into the variables that are being stored in that object. So come down here. It's saying that dog should receive an argument for name. Name is going to go in as a parameter or an argument. Dog should also receive an argument for color. So we're going to comma separate it, throw in color. And it's saying that num leg should have get set to 4. So that's not incoming data, right? Because when we're creating our dog, all dogs have 4 legs. So we're not going to take dynamic data in for that. We're just going to set that ourselves, or hard code it in. And then it says terrier should be constructed using the dog constructor. So what we're going to do is we're going to say this dot name is equal to name. And what we're saying is take that data from the arguments or the parameters and store that in this object called dog. And we're also going to do that with color. This dot color equals color. And then we are going to this dot num legs, and we're going to just hard code that right to 4, because all dogs have 4 legs. Well, most dogs have 4 legs. And then we're going to construct it. Someone want to write out the constructor for me? close. What do we start? And we're not going to call it new dog. We're going to call it terrier.
Equal new space. Capital D dog.
Yep. And then what are we going to put in the parentheses?
Name color.
Well, free code camp helped you out on that one.
What? Oh, it did.
So we're gonna pass in any name and any color. And we're gonna run it, and we got it. Everyone good? Awesome. All right. So now we're gonna use another special word called instance of. Um, so whenever you use that constructor to create, like in that last example, we did a new dog and we called it terrier. We can use instance of to figure out what terrier is. So if we go, oh, what's this terrier thing? We can run instance of and see if it's a dog. So in their example, what we did, they created a bird. They used the bird constructor and created a object of crow. Then they said, hey, take crow and tell me what it's an instance of. And if instance of is bird, then that statement is true, right? So another example, they create a object straight up, canary, right? But canary does not use the new bird constructor. So when you run canary instance of bird, it's going to return false. So I'm going to scroll down here. They would like us to create a new instance of house using a constructor, pass it a number of bedrooms, and then use instance of to make sure that it is indeed a house. So we're going to make our constructor. We're going to let house equal a new house with 4 bedrooms. And then we are going to console log whether my house, sorry, I named that variable wrong. My house is instance of house. And we get true that pops out. Now if we come down here and just say let second house equal just a new object, right, with num bedrooms. When we change our my house to a second house, we're going to have false that comes out because the second house wasn't created using the constructor of house. So we're going to change this back to my house. We'll comment that out. Go ahead and run it. And we got our check. Awesome. Onwards and upwards. Okay, so now let's play around with some properties. So we're back to our bird example. Bird has name passed in. It has num legs. We create our 2 birds, one called duck, one called canary. And name and num legs are this thing called own properties, right? But what's interesting about this is that because we're creating 2 instances of bird, those are stored in 2 separate variables. So anytime that you do a new bird, what it's doing in that constructor is initializing these 2 values in a separate variable that we can access later. So they would like the own properties of canary to the array own props. So we're going to come down here. Own prop should include the values num legs and name. So we are going to use object.keys for the first time. So we are going to use our for loop. Now we're using a for in loop here, but we haven't quite covered for in yet. We're going to use it only because this example is here, but we could also write this as a for initializer value to check and incrementer if we wanted to. What this is basically going to do for us is instead of us having to write out array.length and all of that stuff, we loop over arrays all the time. So when we come in here and we say for let property in canary, we're going to just console log property and we're going to see what's happening in here. And our console log isn't going to run because I have to spell property right. And out comes name and num legs. So what that's doing is that's going up to canary and it's looping over any properties that are in bird. So we have our name and our num legs that came out. And we can do our own props. And we are going to, how do we add to an array? We're going to push in our property. And we get it. Would anyone like me to write this out as a for loop that we've been using? Sure. So what we're going to do is we're going to say for let I equal 0 while I is less than canary dot length I plus plus. And then we're going to say let property equal canary sub I. And then we can console log out our property. And I'm going to comment out this code so we don't forget about it. And, oops. That does not appear to be running. So let's do a couple checks up here. We're going to do a console.log canary.length. Interesting. So canary does not have a length. So we're going to do a new keyword here. We're going to do this thing type of. And what type of is going to do is it's going to tell us whether canary is an object, or it's an array, or it's a string, or it's a number. And so what this is doing is it's saying, hey, canary is actually an object. So what's happening here is if canary were an array, this code would run fine, right? But what this for in is doing is it's specifically looking at the keys of the object for us. Canary is going, it's an object. Objects don't have lengths. Only arrays have lengths. So what we would actually have to do in here is say, instead of canary as an object, we would have to say object.keys. And what object.keys is going to do is, I'm going to console log that out. Is it's going to return an array of the keys. So I'm going to be a little more clear with my variables, and I'm going to say canary keys. And now object.keys is going to look at the keys in canary, and it's going to return that as an array. And we know it's an array because we can console log type of canary. We can actually do array.isArray, because in JavaScript all arrays are technically objects. And we're not going to get an array. Okay, we're going to console log out our canary keys again, because this is not working as I anticipated. We're going to look in the real console instead of the free code camp console. Blow that sucker up. And name and num legs is coming out. Interesting. I'm wondering if we're getting blocked here by this extra thing that's saying, hey, don't cheat and use object keys because we want you to use this for in loop. However, if that were not there, we could use our canary keys in here. We would iterate through our canary keys, which is an array. We would pull out that property in the array, and then we would be able to push it right in this loop, just like we did down here. We good? I'm going to comment that one out, and we're going to put this one back in. Oh, well, now it's mad at me because I used object keys. Comment that one out as well. It's mad at me just because the comment is in there. There we go. Okay. So, what did we talk about last night, other than unplugging HDMI cables? Higher order functions and the general concept behind higher order functions. Why do we use them? Because we want to keep our code readable and don't repeat yourself, dry, right? And so object-oriented programming is another method in addition to using higher order functions that keeps your code dry. So I'm just going to check the stream is still working. Okay. So we are going to say we're going to add a num legs because num legs is the same across all the animals. Use prototype. So Beagle should have a numLegs property, Beagle.numLegs should be a number, and numLegs should be a prototype property, not an own property. So there is, instead of initializing the property numLegs right in the object, we can also do that after we initially set up the constructor. So what we're going to do is we're going to say dog.prototype. And what that's going to do is it's going to say, hey, all dogs are going to have a numLegs property. And we are going to set that equal to 4. And if we run it, let's see, we got it. So what we're going to do is we can play around a little bit here, right? And we can say, all right, well, we created this beagle. So we are going to create a dog2 called Snoopy2, and we can console.log beagle.name, and we can console.log beagle.numLegs, and we can also console log our dog2.numLegs, and we see we have access to Snoopy, and copy this over too so we can see that happening. We have Snoopy, and Snoopy has 4 legs, and Snoopy 2 also has 4 legs. So even though we only set it on dog, because the beagle and the dog 2 are objects that were constructed using dog, and the dog prototype has num legs. It will still work. It's a little weird to do it inside the function. If you were doing it in the function, you would just do it as an own property as opposed to as opposed to outside. We're gonna get to that in a second. So I'm gonna put that back outside, and I'm gonna take these out, and we will keep going. Okay, so we're going to iterate over all properties, and we're going to differentiate between whether it was a property defined in the constructor or whether it was a prototypical property, right? A property that we set using prototype. So they're just rehashing how we set them. So we are going to use, I am guessing, our for in again. So we're going to say for let key in our beagle.
You stop streaming.
Probably the HTML. I will. That's something to note. Whenever the HDMI comes out, the stream gets messed up. Whenever because I also had a resolution issue in the other room, where if you set it down to 720, which looks better on that TV, OBS got really confused. Okay, so we have our for let key in Beagle, and we're just going to console log out our key and see what's happening here. And we have our name and we have our num legs. So let's look here. We have our name that's set as a own property, right? It's set up in the constructor, but we also have num legs set in the prototype. So sometimes it's helpful to know where num legs is getting set. Is that getting set when you created the object, or is that getting set as kind of an overreaching, hey, all dogs have four legs? So what we're going to do is we are going to use this function that they tell us about up here called has own property, right? And what do you think that's going to do? Exactly. So we are going to console log out here beagle dot has own property. Thank you. Of key. And the first, and I'm also going to add the console log of the key so we can tell what iteration of the loop we're on. And name says true. Name is in its own property, as opposed to num legs, which is not an own property, it's a prototypical property. So we're going to say if the key has own property, then where do we want to put that? The variables, the arrays that we already have created for us. If it's an own property, we want to put it in right. So we're going to own props, and how do we get it in the array? Yep. We're going to push the key in, and if it's not, we're going to else prototype properties dot push, and we'll push it into there. And we'll run it, and we got it. Yeah. I did. Let's switch scenes and maybe. No, my screen is frozen even in OBS. There we go. Anyone need help before we go on? Uh-huh. No problem. All right, so we are creating dogs. I'm gonna just bump up your brightness a little bit here. Okay. Oh, that's okay. I can read it. Yep, we're good. Um, so no problem. No problem. And we're actually you're not too far behind. We're actually so you're not behind at all. That's the one that we just did. So we're on line 13. So if you just follow the for loop up there, we want to separate it out into two arrays to figure out whether it was a own property made in the constructor or a prototype property that was set later. So what we did is we did a for loop to run through each of the keys or the properties in the object, and then we use a new function called hasOwnProperty on the key to figure out whether it was an own prop, and if it was, push it into the array. Otherwise, we're going to push it as a prototype property. Anyone else need help? Yep. All right, got some bracket puns going on here. So 18 looks wrong to me. There you go.
Thanks.
All right, I'm going to move on. Not going to move on. This is the only code that we changed. So I would just jump to the one that we're on. And I'll, yes, it does. If you go to the curriculum, it will let you jump to the one that we're working on. But you're almost caught up. Iterate over all properties. We are on. Let me check. Yes. I'm going to move on. Dave's here to help in case you guys need it. Dave, do you have the live stream up? Okay, perfect. Thanks. All right. So now let's talk a little bit more about constructors. New constructor property dot constructor prints true. So we can tell whether the object that we have created is coming from a constructor. The overwritten. It's better better to use instance of. I personally have never used .constructor. I've always used instance of, and even in the free code camp instructions, they're saying that constructor isn't the best property to use because you can actually overwrite it. You can actually go, yeah, constructor's built in, but I want to use constructor for something else. So they're saying it is generally better to use instance of, but we'll drop down here and knock this one out. So join dog fraternity should be defined as a function, right? Join dog fraternity, it is a function. It should return true if candidate is an instance of dog, and it should use the constructor. So let's console log out candidate and see what they're passing in as candidate. So candidate, and we're going to run that, and nothing's going to come out. Okay, what we're going to do is we are going to return our candidate, see if that has anything come out. It is not. Okay, so we are going to return candidate.constructor. Maybe I just have to call, I don't know what their test cases are doing. The join dog fraternity, it's not, but their test cases should be calling it, and I guess they aren't. I think what they want is join dog fraternity, and they want a new dog. I have no idea. Let's take a look in our actual console and see. Hope if I console logged it out. Okay. So we console logged out our joint dog fraternity. We created the dog and we called the dog Doug. That came up to the function. The function got the name, set the name as an own property onto dog. Then we pass that information into the joint dog fraternity as the candidate, and the candidate returned the constructor that was used on dog. Right, so that's why we have function dog coming out here. It's basically telling us, hey, the constructor that we used to create this object is this one right here. So that's the point of the constructor. So join dog fraternity should be defined as a function. If we run that, we got that. Join dog fraternity should return true if candidate is an instance of dog, and it should use the dot constructor property. So I'm going to come back up here, and what we're going to say in here is we're going to if candidate dot constructor is equal to dog, return true, else return false. Thank you. And dog should not be in quotes. So that's just another way of using instance of. Um, instance of, again, is generally the preferred way of doing it, but because we have some legacy things hanging out in JavaScript, constructor can be used instead of instance of. So if we change this line out to instance of, and we use a parenthesis instead of a triple equals, we lose it. Candidate is a new dog. Let's go back just so we can look at instance of again. Instance of, no parentheses. That's what I was missing. So candidate instance of. This is just another way of doing it. So if we run this, we pass the fact that it is actually checking whether it's an instance of dog or not. So basically, this is just another way of writing it. Good? Okay. Okay, so we are going to change the prototype to a new object. Okay, so we're going to add the property numLegs and the two methods eat and describe to the prototype of dog by setting the prototype to a new object. So we are going to say dog.prototype. And we are going to add numLegs. And do they want that set to something in particular? Nope, so we will say 4. Does what need to be there twice? So we have to, oh, thank you. Nothing to apologize for. Our right, we are going to add our eat property, and eat needs to be a function, so we will define our function, and we'll just console.log dog is eating, just so we see it. And we can also add our describe and function, and in here we will console log dog has num legs plus legs, just so we put something in there. And we will spell describe right. I don't know why I cannot type tonight. And we'll run it, and we got it. And basically, the point of this exercise is saying that if you want to set multiple prototypical properties, instead of saying dog.prototype.numLegs is equal to 4, and then dog.prototype.eat is equal to this function, you can just do it all in one swoop and go, okay, I want to add all of these to the prototype of dog, and so I can just say dog.prototype and pass in all that information instead of writing out dog.prototype.numLegs, dog.prototype.eat, dog.prototype.describe. That's all they're trying to say in this one. Good? Awesome. Okay. So when we set our prototype to a new object, when we pass in some more information to the prototype, it erases our constructor. So when we console log out duck.constructor, it goes, I don't know what the constructor was. You changed the prototype. We lost track of what you used to construct it. So when we modify prototype properties, we also want to pass back in the constructor so the computer remembers, hey, we changed the prototype, but this is how we created bird. So what we're going to do in here is simply put back in the constructor, and we're going to say the constructor of dog is dog. And we'll run it, and we get it. And the reason why Free Code Camp covers this stuff is because when you set a prototype, this isn't something that you think about as, oh, I'm overwriting the constructor. But this just helps the computer remember, hey, when I'm changing the prototype, right, the properties of the object, we have to reset the constructor. All right. I'm just going to do a quick check on how far in we are here, where an object's prototype comes from. All right, we are about halfway there. Okay, so now let's talk a little bit more about why we have prototype versus own properties. So prototype is all about inheritance. So in the parent, right, if we think back to the DOM in HTML land, we have our parent and our children. We have our div tag, and our div tag may have a couple p tags in it. Prototypes and objects have a similar relationship, where the prototype is the parent, and then anything that we set in the object itself is, it will copy in whatever is in the parent and then allow us to overwrite it in the child if we want to. So in this example, we have our bird, which is our object. We pass in the name. We create our bird using our constructor, and Donald comes out. So maybe I got a little bit ahead of myself in the exercises. they want to see that Beagle, um, show the dog.prototype is the prototype of Beagle. So let's console.log our Beagle dot is prototype of, and we're gonna pass in dog here, and we're gonna run it. Is prototype of, oh, I did that in reverse, sorry. We're gonna say dog dot prototype dot is prototype of Beagle. And spell prototype right. And we got it. It's kind of a silly example because, of course, dog is going to be a prototype of itself when you construct it. But let's see if we build on something here. All objects have a prototype. A prototype is itself an object. Okay, so what they are saying is that is prototype of is actually defined in the prototype of the object itself. So dog.prototype is prototype of Beagle. We know that because the prototype of dog comes from the dog prototype. Seems a little redundant here. So your code should show that object.prototype is the prototype of dog.prototype.
So just type object.prototype and get that.
Should show that object.prototype, right.
So
So basically what we're proving here is that when we created dog, right? We created dog, and dog is an object. And so because we created this dog object, the the object itself had a prototype, had a parent of object itself. And the object itself has these properties in it like is prototype of. And so we have some inheritance going on here. And that's what I think they're really trying to hammer home, is that when we look at this code, we created dog. And since dog is an object, it went up to the parent prototype of object, and it went, oh, object has a bunch of things defined on it, like is prototype of. And that's why we can use functions like is prototype of on our objects. In fact, if we console log out dog, let's see what it comes out with. No, it's not going to let me access it that way. It's going to let me access Beagle. No. I'm going to try and come up with some real world examples for you guys on prototypes, because I know it's kind of hard to wrap your head around why you would use a prototype as opposed to an actual object. I seem to remember FreeCodeCamp doing a better job at that. Okay, so we're back to dry, which is good. We have our bird prototype, our dog prototype, describe, Here we go. Now we're getting into some real world stuff. So this should start clicking here. All right. Exactly. Exactly. So we have a cat, and we have our cat prototype. We have our bear and our bear prototype. And in both of these, we have eat, and we notice eat is being repeated. We don't want that. We want to be dry. So what we're going to do is we're going to create a structure here. We're going to have our parent or our super type of animal. An animal is going to have the cat and the bear as well. So what we're going to do is in our animal prototype, we are going to take eat and we're going to put it down there. And then we're going to take eat out of cat and we're going to run this. Now, I'm going to check the next one and then come back to this one, because if they don't do what I want them to do in the next one, we're going to do it back there. Yes, they do that. Okay. Anyone confused on this one? We're going to see why we just did that in the next challenge. Everyone good? Okay. So now we moved eat into animal, right? And so what we want to do is create animal prototype, this challenge and next challenge, super type, new animal, create prototype. Okay. So what we are going to do in here is we are going to say let duck equal, we're going to say object.create, and we are going to pass in the prototype of what kind of object we want to create. So we're going to say animal prototype. Now, typically you would use a constructor to just say let duck equal a new animal. But we're going to see in a minute why they're teaching us object.create. So we'll do the same thing here. And we're going to create two objects using that animal prototype.
I did it with new and it worked.
Did they tell you to?
No.
Oh. So personally, I would use new and just say equals new animal, but object.create is another way that you can avoid using the constructor and use object.create instead. I've never seen object.create used instead of a new constructor, but Free Code Camp wants to cover it. And the reason why they do that, by the way, is because as a developer, you'll be getting into a lot of other people's code and trying to read it. And some other developer may have learned object.create or may have been coding in JavaScript for years before the new constructor was around. And so you'll look at this and you'll be like, object.create, what's object.create? And you go, oh, I remember Max talking about that and saying no one ever uses this, but I proved him wrong. Someone does use this. Um, the new constructor is what's typically used when you're working with objects. Okay, on to the next one. We're getting close to an explanation of why we're covering all of this, I promise. Okay, so we are going to set the child's prototype to an instance of the parent. So we're going to link the child to the parent right now. So we are going to say bird.prototype is object.create animal prototype. The prototype is like the recipe for creating an object. So it's going to describe the, it's going to have the property set that we're going to inherit in the child. Duck inherits all animals' properties, modify the code so that dog inherit from animal. Okay, dog.prototype should be an instance of that. Okay, so we have our new dog, and what we're going to say here is we are going to say the dog prototype is equal to a object.create animal.prototype. And then I'm going to comment out this line so we can talk a little bit about why we want to do this. Next time someone sees me spell prototype wrong, just come up and slap me. Okay, so we're going to run this. We got it. So let's talk about what just happened here. So what's happening down here is we created a new dog and we said, hey dog, eat. And what happened is if we scroll up here, animal has this eat function created. So what we said in dog.prototype is we linked the prototype of dog, the parent element of dog, we linked to the animal. And so what happens is when dog is created, dog doesn't have any own property, so it doesn't have any information in it. But what we said is we said, hey, when you create dog, also copy in, reference in anything that is in the animal prototype as well. So the flow of the code here is actually none of this does anything until we start getting down here. And we get down here, and even the dog.prototype doesn't do anything quite yet. We say new dog. And it goes, okay, you want a new dog. What's a dog? A dog is this function. It's going to be an object. And now we have let's look at how we create that dog. In order to create that dog, we need to look at the prototype of the dog, the parent of the constructor, right? The animal doesn't have any properties. But the parent of animal, the prototype of the animal, has a function called eat. And that eat is defined in here. So when we come down here, now new dog is created, and that new dog, this beagle, goes, okay, I've copied in any of the prototypes functions as well. So any of the parents functions, so now I can access eat. So when I call .eat, it goes, all right, well, .eat isn't actually in dog, but because it was in my parent, I know how to eat. Yes?
So in theory, sticking with like the animal stuff, like you could give different, you can make different like animal functions with like sounds, right? So you could have like a dog one, like a cat one or a bird one, right? And then if you had different kinds of like a dog or a cat or a bird, you would call to that specific function for that sound based on like whatever.
Correct.
So that's something that I don't know if we would use that, but okay.
So we're going to keep going, and I believe they have examples of something like that.
Yeah.
Reset inherited. Of course they don't. All right, well, let's see where we're at. Prototype. Okay, so we're going to add methods after inheritance. Yeah, all right, let's get through this one, and I believe the one after this will cover more use cases on prototypes and constructors. So bird prototype should be, well, let's run it first and see how many of these they've done for us. Okay, bird prototype should be an instance of animal. So let's confirm that that's the case. We have our bird prototype and we're creating off the animal prototype, which means that anything in the animal would be able to be accessed by bird. The duck constructor should return bird. Okay? So what we want to say here is we took care of so we are going to say because we set the prototype of animal, we lost the constructor property, right? That's what we covered 2 or 3 exercises ago. So we're just going to remind the computer, hey, we set the prototype. We told you that the prototype of bird was animal, but we still want to remind you that the constructor is bird. So we're going to say bird.prototype .constructor equals bird. And we're going to do the same thing with dog dot prototype dot constructor equals dog. Run it, and we got it. So that's just a reminder when we set a prototype, when we set a parent, we want to remind the computer what the constructor of the child is that we are overriding the prototype on. Okay, so we have our animal here. We go into the prototype. We say we're going to define this function called eat. We have our bird in our prototype. We associate bird with an animal. And because we are setting the prototype, we also remind the computer what the constructor of bird is. So we are going to create on bird, we're going to create a prototypical function called fly, and we'll be able to access that on bird. And then on bird, we can call eat because the animal has access to eat, but we can call fly on bird. But if we tried to call fly on dog, it would be like, what are you talking about? Dogs can't fly. And the reasoning for that is because we set fly at the bird level, not at the animal level. Okay, so we're going to do the same thing with bark. We're going to teach a dog how to bark, and the dog's going to know how to eat, but the dog's not going to know how to fly because the fly was set at the bird level. You're starting to see why we would use objects, hopefully a little bit? Okay. So we have our animal. We set our animal prototype to eat. So all animals know how to eat. And we have our function dog. So what we're going to do is we're going to say, first of all, we need to say that a dog is an animal. So how do we do that? Great. Now we have that. So if we come down here and we run beagle.eat, look what's coming out in our console. So just because we said, hey, the prototype of dog, the parent of dog is an animal, we now have access to nom nom nom. And if we comment this line out, we suddenly lose our nom nom nom. Okay, so now we've associated our dog with the animal. And now we need to define what bark is. Now they want bark as an own property. So where do we set that? And the constructor is online. 4.
Oh, I thought you meant like where you put it.
Add. So if they want it as an own property, why are they saying add your code below this line? If it's an own property, it should go in here. It should say bark function and this dot bark is equal to a function. Sorry, it was a little off there. Is equal to a function console.log wolf. And let's run it. So this is what this does is it associates it with the object that we're creating.
It's like the function's like this thing that I'm inside, that's what I want to reference.
So if we just called it bark, it would just be like, oh, you want this thing called bark? I don't know why. But when you say this dot bark, you're saying, hey, all dogs have something called bark.
Okay, and that's what you were saying. It calls back to the function that is inside.
Exactly.
Okay.
So what if a function has parameters in it?
I'm sorry. Ask that again.
I was what if a function has parameters, like multiple parameters in the brackets? Do you still use this?
So, yep, you would still use this. You're saying if we put a parameter in here, like what bark,
Yeah.
then we would come in here and say console.log dog says what bark.
I was saying in the animal.
Oh, in animal up here?
Yeah.
The this is only referencing the dog.
Right, we're using this in the dog. So if we wanted to write a own property of the animal, we would use this in here. We would say this dot
So it's referencing the function's name and not.
exactly. So if we said this dot planet equals Earth,
Cool.
um, it would this is referencing animal because it is in the curly braces of animal, as opposed to this, which is referencing that dog object.
It's only one level deep.
Right. This is context aware, right? We're talking about this. Where are you using this? So this is going to be associated with animal in this case, and this is going to be associated with dog. That's the bark.
Thank you.
What I am wondering is why I am not getting the constructor for beagle should be set to dog. Let's take this out for now.
I put mine all underneath the dog prototype. And it worked.
You said
I didn't make it an own property because it didn't work like that. And I wrote it carefully.
you did like dog.bark.
I did dog prototype bar.
Like this.
But then it's not an own property.
I know.
Dog.proto.
I did that with the constructor, and then
Did I?
the function.
Let me delete bark. Let me delete. Oh, I have a syntax there. There we go. And now I screwed with something else.
Because I did this.
The constructor of dog, right? Okay. So because we modified the prototype of dog, we also have to remind the computer that the constructor of the dog was actually a dog. Okay. So prototype bark. I think this is a mistake in pre-code camp because when we set bark, we're very clearly saying that bark is a prototype function, not an own function, right? Own functions are when they are defined in the constructor.
Yeah.
So I think this shouldn't say own property. I'm pretty sure this should say prototype property if they want this test to pass. So I think this is a mistake at free code camp.
Should I tell them that? You messed up.
Yeah, you can go onto their GitHub and find their curriculum and open a pull request. Gus covered pull requests, right?
Mm-hmm.
So yeah, you could, well, so there are two things you could do. You could open an issue, and when you open an issue, it's always nice to include the fix for the issue as well. So you would navigate through the code. You would find where this is written out. You would edit it, and then you would create a pull request and say, hey, if we're setting it through the prototype, then it shouldn't be considered a known function. Cool. All right, on to the next one. So now we're going to talk a little bit about overriding, right? So we have our bird, and we set on the bird prototype that birds can fly, because that's true for most birds, and then we create a penguin, and we go, wait a second, penguins can't fly, but they are birds. So we're going to make sure that that thing that we inherited from the prototype in the when we create the penguin and we say it's a bird, we're gonna say when we inherit that fly method, we're gonna change fly. So what we're going to do is we create our animal and we define our eat method and we define our bird and we say that birds are animals, and then we do animal.eat. And then in our bird prototype, we're going to override what eat is defined as, right? So we're going to do the same thing over here. We're going to say we have our bird, we define the fly on the bird prototype. Then we have our penguin, and we associate penguin with our bird. And then we remind the computer that, hey, because we changed the prototype of bird, we also want to remind it where the constructor came from. Now we come down here and we say penguin dot prototype dot fly is equal to a function that returns what they tell us it should return. And we're going to run it. And we're going to spell penguin right. And we got it. So there are definitely times that you have inheritance set up, and there are values in having inheritance set up, but you just want to override it for the child, but not for the parent. Which is why when we come down here, if we just say let bird equal new bird, and we bird.fly, we get I am flying instead, because we only changed it on the inherited level. Okay, how far did I say? We got 2 more to do, and then we will take a quick break. Okay, so behavior shared through inheritance. There are times that inheritance is not the best option. There are times like bird and airplane, they can both fly, but bird is not an airplane. So we can use mixins. And what the mixin is going to let us do is fly mixin is defined up here. So we are going to say, okay, let's define this new function, and that function is going to take a parameter of an object. And that object, we are going to associate a new method with that object. And that method or function, by the way, function and method are synonymous. That new function that we're going to create is going to be defined as flying whoosh. And then when we create our bird and we create our plane, we're going to say fly mixin bird. Bird gets passed in to our function here. And what we do is we associate this new function of the bird object with flying whoosh. So let's take a look at how that works in our actual code. So we are going to create a mixin. So we're going to say const glide mixin, and glide mixin is going to be a function that takes an object, and that object is going to have a new thing associated with it called glide, and they They don't tell us what glide's going to do. So we're going to say it is going to be a function that console.logs I'm gliding. And then we're going to drop down here and we're going to say, okay, glide Mixin. And we're going to give it the boat. And we're also going to glide Mixin onto the bird. And we'll run that. And we got it. So let's go through what's happening here. We have a regular object bird. Didn't use a constructor. It's just a regular old object, right? And we have our boat. And we set up our boat. Again, nothing fancy here. We could create objects for this. We could use constructors. We could go through prototypes. But there are some times that we just want to use straight up objects. And 99% of the time, when we're going through these algorithm problems at least, we don't need constructors. We don't need to use prototypes. We can just use our regular objects. When we get into more of React land, all of this stuff is going to be in the back of your head, and it's going to come up of, oh, look, we're using inheritance to set up a component, but down the road. So what do? We create this thing called glide Mixin. Glide Mixin is going to be a function that takes a parameter of object. Okay, object is going to have a new key associated with it called glide, and whenever we call glide, we're going to run this function called console.log I'm gliding. So when we come down here, we can console.log our boat.glide, and we get I'm gliding. Now, if we take our glide Mixin and don't associate it until later, we don't get anything with our code, right? Order matters here. So we said, hey, boat.glide, and boat comes up here, and it's looking at boat, and it's going, boat doesn't have a glide. What's glide? I don't understand. This glide Mixin code is not going to run until we tell it, hey, glide Mixin, here's this boat, mix in the glide function. So when we put it up here, we have a flow going on, right? All right, glide Mixin, take this boat object. Boat's defined up at the top. Okay, glide Mixin's going to go to this const. It's going to look, it's going to get that object. Great. Now that object is boat. Boat.glide. Okay, define this new function, defined as glide, and console log out I'm glide. Yes.
Question. So when you say return, it ends the function, right?
Yes.
Unless you say like else.
Unless it is in an if
there,
else.
but then it'll go somewhere else.
Correct.
So if you only have one thing, like one thing inside your function, does it matter if you use return or console.log?
It depends what the intended intent is on it. So if I take out my console.log here, because I defined it in my function, it's still going to console log. Right? But if I return it here, which is probably a better thing to do, nothing's going to come out until I put this in my console.log. So the reason why you typically use returns instead of console.logs is because when you call the function, you're going to do something with the data. So the console.log is just for you to see it. But if I console logged in here and then wanted to, so like let's say I console.log instead. And then I say, in here, I say boat.glide, and I want to boat.glide and put at the end of it, and having fun. Well, I get I'm gliding because it console logged up here, but then I get undefined and having fun because this function isn't returning that. And ideally, I don't want it on two separate lines. So that's why it would generally be better to return here, and then I get exactly what I want in the console. That's a great question. Good. All right, one more, and then we'll take a break. Ooh, closures. Maybe we'll take a break now. Um, yeah, let's take a break now. We'll do closures when we get back. And then we are going. Closures are super important. Definitely going to cover it. But a fresh mind would probably be good for them. So we will take a break. We'll cover closures, and then we'll figure out where we want to go in terms of algorithms or stuff like that. So it's 7:07. Be back around 7:20ish. All right. So I'm gonna go over to the whiteboard here and try and redeem myself, and then I promise I will get back to the closure problem. I'm not.
Procrastinating.
I'm not procrastinating that one. That one wasn't as bad as I thought it was gonna be.
It's called
I'm gonna take a
conceptualizing.
what?
There is no procrastinating. I changed the word to conceptualizing.
I will take a picture of this and post it in the Google Classroom because it won't show up in the stream. But I took our animal again, and I took our dog, and I wanted to run through these situations that are going to happen here, and just conceptualize why we would use a prototype, why we would use an own property, and what's happening with that association, right? So we have our function animal, so we're creating our object here, and I set an own property on the animal called planet Earth, okay? And then we have our animal prototype, and we have eat, and we define eat as a function, and we return none, right? So this is just our animal. So if we create any animal with our constructor, right, const any animal equals new animal, we could, in theory, console, I didn't write it, but console log animal.eat, and it would work fine. And the reason for that is when we say, hey, construct our new animal here, it's going to go up here, and it's going to say, okay, our animal, every animal has something, own property, planet Earth, but look at the prototype of animal, and every animal also gets this function called eat, and it returns none. And we could override that if we wanted to. All right, great, all of that makes sense. Now we come down here, and we have our function dog. And our function dog is a breed, it takes a parameter of breed. And that breed we set as its own property, right? This.breed equals breed, and we also set num legs there, just because we can. Now this prototype line should come in right here. So what we do is before we construct any dogs, we say, hey, the prototype of dog is connected to the animal prototype. So when we create our dog, we're saying, all right, dog is going to have num legs and it's going to have breed, but it's also going to have any of the prototype functions. What it's not going to have is access to planet Earth, because the animal has its own property of Earth, but because it is not a prototype property, anything that uses the inheritance of animal is not going to have access to Earth. So let's look at that in code form instead of conceptually. We have our const Fido equals new dog. And we said new dog. All right, great. Dog is going to have num legs and it's going to have breed. Now let's look at the prototype of dog and pull in any of the prototype data. All right, prototype, object create animal prototype. All right, that's going to come up here. All right, what are the prototype functions of animal? That's eat. Okay, dog will have access to eat. But we're not coming up to the animal, the own properties. We're only looking at the prototype properties. So when we jump down here and we say, okay, console log Fido.breed. Okay, Fido is a dog. We constructed our dog. When we constructed it, we passed in pug. So we're going to come up here. We're going to look at dog. And this.breed is pug. So where you will console log out pug. Okay, now we're going to have our console log Fido.eat. Okay, we're going to go back. Dog. Dog is up here. But because we set the prototype, dog is also going to have eat. So eat is going to return nom. Nom is going to come down here and console log nom. Great. Now we're going to drop to console log Fido.planet. So it's going to go and it's going to go, where's planet? It's going to go up to the object, the function, and it's going to go, okay, there's no .eat, there's no this.eat, there's no own properties on that. All right, maybe it's in the prototype. Let's go look in the prototype. All right, is there an animal.prototype.planet? Not in the prototype. Animal has its own property called planet, but because it's its own property, it's not going to share it with things that inherited through the prototype. So when we drop down here, it's going to it's a lot to take in, which is why I'm pausing. If you guys can formulate a question, it means you're understanding it.
We probably went over it, but how do we get the dog to live on Earth?
So great question. So in order to get the dog to live on Earth, we would animal dot prototype dot Earth. I'm sorry, dot planet. And that would equal Earth. And now we don't.
Property versus the prototype thing.
Exactly.
Okay. Legit.
I still don't get the own property. I know I'm going way back.
Okay, so the own property, the reason why we have own properties is there are times that animal.
Oh, that's the one you're explaining?
That's the one I was explaining, where before, if we didn't do this prototype and we defined it in the own property instead, dog wouldn't know what planet it was on. But because we put it in the prototype instead of the own, dog's now going to know what planet it's on.
Okay.
So prototype properties get inherited when you associate them, but own properties do not.
And what's the difference between prototype, instance of, and
So prototype is going to they tell you instance of is the better one to use because it's going to tell you there are times that you can override the prototype or the constructor. And so to use yesterday's term, the TLDR of it all is just use type of. And that's going to tell you, hey, what's the type of Fido? And the type of Fido is going to be dog. So I would say out of all of this, I wouldn't get too worried about has own property or type of or dot constructor or any of that stuff. The most important thing to understand here is how the inheritance is working. How does animal have access to eat? And then how does dog have access to eat? And the reason that animal has access to eat is because it makes, right now, because that's crossed out, it just makes an empty animal, right? And it's this function called animal, this object called animal, but as soon as it goes to make that, it has to look at the animal prototype and it goes, oh, my parent, my template, think of a prototype as a template. My template says that all animals have a planet Earth. So I'm going to put planet in here. And if I wanted to override that for some reason, I could. But the reason I'm going to put it in my prototype is because I want my animals to have access to it as well. I want my children, my dogs, my whatever else that I create. So I'm going to create anything that I want to be inherited down the chain. I'm going to make a prototype property. Anything that I want to kind of be on my own and only have animals have access to, but not the types of animals to have access to, I'm going to put as my own properties. And then when I construct them, I can actually access all of them. So these are just like the placeholders. These are saying, okay, you made this type dog, but now we need to make the dogs. Right? Dogs are fine, but now you need to go make Fido and you need to go make, all of your instances of the dogs. And in order to do that, that's when we use this breed instance, right? Because breed is going to be different for every kind of dog. So when we create our new dog here, we pass in pug as the parameter. So now we can do a const Fido equals new dog pug, and we can do a const Doug equals new dog shepherd. And if we do Doug dot breed, we're going to get because we inherited that all the way up. Good. So I think now that we went over this, it might be helpful to go back through the free code camp exercises tonight after class. And it may start to click a little bit more. There are a lot, I feel like we could have cut half those free code camp exercises out, and had we done that, it probably would have made more sense. And I apologize, I should have done that in advance before the class. But if we think about it just as what's inheriting, what do we have access to, and where do we put it in order for that inheritance to work on the prototype, then you guys should have a clear concept of inheritance. And the good news is, if this seems a little complicated, there is a way that I was just showing Dave during the break that is 10 times easier. And every other programming language uses it. And eventually with JavaScript and ES6, they went, screw it, we'll do it too. And so the newest version of JavaScript uses something called extends and constructors. And those constructors are just 10 times easier to wrap your head around. But I'm going to steal that from another instructor if I show you it now. So the reason why I'm only showing you this is because this is how JavaScript has worked for the past 25 years. And this is how you've managed to do inheritance in JavaScript, which is an important concept in any programming language. Now, as of 2015, but it hasn't really started to come into use until 2017 and 2018, there is that new constructor method and extends method, which not quite sure which instructor is going over it, but I know it is in the curriculum. So you guys will see this again, but instead of using prototypes, you're going to be using classes and extends. Okay. So I kind of just covered this over there, but we're going to do it anyway. The point of this exercise is to say that, hey, we want to create this property in bird called hatched egg. So instead of doing this dot hatched egg, we're just going to do a let. Give it a second.
Which lesson are you
on? I am on use closure to protect properties. So I'm going to, instead of this dot, if I did, in this example, if I did this dot hatched egg, then down here, when I create my bird called ducky, I could say ducky dot hatched egg, and it would return that information. But we don't want that. We want to keep hatched egg as private. And then we're going to create a new function in here called this.get hatched egg count. And because of that, we can access that information now. So let's dive into maybe why we want to do that. So we are going to create a new bird here. Well, we'll pass it first, and then we'll dive into why. So we're, instead of this dot weight, we're going to say let weight equal 15. And then in here, we are going to do a this dot get weight, and that's going to be equal to a function that returns the weight of the bird. And if we run it, we passed it. So this is all you need for this challenge in Free Code Camp. I'm going to dive into a little bit more on why you would want to do this, though. So if we're in here, we can create our bird called Ducky, who is a new bird. and we can console.log, and if we do ducky.wait, we're not going to get any information back. And that's because this bird, this wait, it's a private variable. When we create new instances of the bird called ducky, it doesn't have access to wait. But we can do get wait because get wait is a public function, is a public method because we said this.getWait. The other thing that this does is it makes it so we can't change the bird's weight. So if we said in here, just put this back, and we're going to say instead of let, if we make this back to a this.weight, in our, once we create ducky, we can say ducky.weight equals 10. And when we console log that, when we console log out the bird's weight, we get 10. But what if we don't want to let them change 10? Now let's go back to making this a let and doing a this.getWeight. So now, if we do ducky.weight equals 10, and then ducky.getWeight, notice it's still 15. What we just did is we said, no, any instance, that's a locked-in property. Any child component shouldn't be able to change that. But they may have a good reason for accessing it. So we will create a public function for them called a getter method, get weight in this instance, that's going to return the weight, but we don't want to let them change it. And so that's how you would accomplish something like that. Is instead of this dot weight, which would make it public and what they call mutable, which means changeable, instead we made it a private variable and then wrote a function that was public to let them access that information.
So is get a keyword?
Get is not a keyword. If we wanted to get, we could change this to retrieve. If I can spell retrieve, I think that looks right. And we can put that down there and it will still work.
So when you have it equal to function and then you have the return weight, is that so it's assigning the weight to the get weight?
The trick is it's public because it's this dot something. So the reason why weight is not public and why we can't change it is because it does not say this dot weight, it is let weight.
I think so it's private.
The weight part is private, yes. The retrieve weight is public because it's this dot retrieve weight.
Oh, so that's why you're reassigning. That's the this dot get weight equals to function is reassigning, right?
It's allowing access to the private variable. Because if we didn't have this retrieve weight, there would be no way for us to access weight.
You could change the variable weight to like pounds, and then say return pounds, and still have this dot retrieve weight, and it would still return the same number.
Yeah, I'm trying to
Is that what you're
understand.
confused about?
No, no, that's not. I was wondering if it's reassignment where you're taking one like reassigning the let weight to retrieve get weight to make it public. And I
So
just wanted to know if you
You're just
needed to use
calling
the
it.
function kind of.
it's not making it public because if it were making it public, we would be able to change it. So all we're doing is allowing it access to the variable, but we're not letting it change the variable. So if we look here, I said let wait, right? And then I console log out my ducky.wait, and you notice there's nothing in the console. So what we just did is, okay, this is a private variable, and no one can change it, no one can access it. But if there was a situation where we wanted someone to access it, but not necessarily be able to change it, that's why we would use this getter method, and then we could put this down here and get that information. But your flow is right. So it's going to retrieve weight is going to go up here because it knows it's a type of bird. Retrieve weight is going to run this function. Return weight is going to come in from 15 here. 15 is going to go here. 15 is going to get returned to retrieve weight. Retrieve weight is going to come in here, and it's going to be 15, and then it will console log out 15.
I was just wondering if we can just have this.getWeight dot retrieve so equals weight. Would that work?
Say it again.
The retrieve equals weight. This retrieve.
Yeah, you're saying that.
Yeah.
So that
Instead of having function in there.
yeah. So if we delete that out, it will return 15. The trick with that, I'm guessing here, but I believe if we do that, we could also do ducky.retrieve_weight dot is equal to 10, and now if we get retrieve weight, it's now 10. So the reason we make it a function is so we make it so it's read only. We make it so they can't change it. Because right now, if you do this dot retrieve weight equals weight, you might as well just say this dot weight equals 15. So the reason we make it a function is so that it's a one-way thing, so that the individual duckies, the individual birds can't change the overall weight. All right. That is it for object-oriented programming. I have I have a link for Khan Academy posted for the homework if you guys want a little extra work with that. We have 40 minutes left in the class. So do you think that would be better spent pair programming, working on algorithms, and various homework throughout the week? Or would you rather me go through some algorithms up here?
Not that I don't like those classmates, but I like you.
Yeah, if you want to walk through the algorithms, that'd be great.
Okay,
Yeah.
that's why I asked. Okay, so the next question is, would you rather work with loops more or objects more?
Objects.
Right.
Okay,
Different options.
Need more.
hands raised. Who wants objects more?
What's more I mean loops
Yeah.
are very I mean both are common.
Both are super common. It's just.
What do you think would be more beneficial right now?
I think we'll have time to get to both. There is one function, one thing that I wanted to cover. Let me pull it up. There is one called Chunky Monkey. And what Chunky Monkey does is it passes in an array of A, B, C, D, and a parameter 2. And you have to go through the array and kind of split it up into groups of 2. Or it passes, 0 through 5, and you have to chunk it up into groups of 3. So that's option 1. The other one that I've been talking up, I think, all week is record collection. Where you get this big object, and the object.
Let's do this now.
Okay. It's keyed by the ID, right? And it has some information in it, and then the challenge is they pass in information and they want you to change that. So you guys want to do this one?
That looks like fun.
Okay. We shall do it. All right, so here's our collection, right? In our collection, it's important to identify in your head what the structure of it is before you dive in and start manipulating it. So collection has keys, and these keys happen to be numbers. Um, the numbers are in strings, though. So they are essentially the ID, and the ID for this key in your collection has an album key that has a title, has an artist with the obvious artist name, and then it has another property called tracks, and the tracks are the album, the tracks on this particular album. Okay, so um, they copy this collection so they can compare what the starting value is compared to the ending value. So we can ignore that. And so what they want you to do is create this thing called update records. And update records takes the ID of whatever you're trying to work on, the property that it wants you to update, and then the value that it wants you to update it to. So for the first one, we're going to go to our collection, and we're going to say collection, and we are going to go to the ID, and we going to use square brackets or dot notation here?
Dot.
Does it matter, first of all? It does matter. Why does it matter? Why do you want to use square brackets instead of dot notation? Because they're passing in a variable and we're looking for the value of that variable, right? So if we said collection.id, what JavaScript's going to do is it's going to go through here and it's going to say 2548, that doesn't equal ID. 2468, that doesn't equal ID. 123, that doesn't, right? So it's looking for literally the letter I and D. So we don't want it to look for the letters ID. We want it to look for the value of ID. And in this case, the value of ID is 5439. Okay, so go look for the ID. And in the ID, we want to go find the property. So we got 2548 and or we got 5439, and we're going to confirm that. So we're going to console log our collection ID. And that doesn't help me at all. We're going to cheat and use something called json.stringify, which just turns the object into a string. All right, and what came back is album ABBA gold. Okay, so if we scroll up, the reason why that came back is 5439 just has album in it. It doesn't have an artist, it doesn't have tracks. So what we're going to do is up here, we're going to say our collection ID, which we know is working because the right object came back from the giant collection object. And we're going to say, hey, set the prop equal to the value. And now we see our artist, ABBA, came in. And again, if we trace that, artist is coming in here to our property. So we're saying, okay, 5439, go to the collection, go find 5439. Now our artist is our property. Go find artist and set that equal to the value that's coming in. Okay, great. You're gonna get a green check mark. Let's try it. You get one green check mark. We celebrate any progress. We don't have to celebrate overall progress, right? In programming, we celebrate different errors. I can't tell you how much of my day I'm just like, it's a different error. I'm so excited. All right, now let's go fix that one. All right, so that worked. We're good there. So now let's come on down here, and I could just reference this, but it's going to be easier if I copy and paste it into here so we can see what's actually console logging out. So they're saying on 5439, if I pass in tracks, take a chance on me as the value. It should have take a chance on me as the last element. So let's go back up and let's look at our structure. Our structure here should have tracks, but tracks should be an array of the tracks. So what's actually happening is if we look at our console log of what's coming out, it's album, ABBA Gold, great, tracks, but take a chance on me is not an array, it's just a string. So how do we solve that? And this is a very important step, right? Instead of just trying to write code or thinking about, oh, well, I know we're going to use push at some point, right? But instead think about it as, what am I trying to do? What's the main objective? So right now, as trying to approach this problem, I would say my main objective isn't to take a chance on me into an array. My first objective is to get the array set up. So let's just get the array set up. So what we're going to do is we're going to say collection ID and prop, which means, okay, we're still going to look at album Abigold tracks, right? And we're going to say instead, we're going to do a equal array, and in that array, we want our value. Okay? And if we move our console log down to after where that's happening, we have our tracks take a chance on me. Great. So let's go ahead and run our tests again.
Can we just go back to where you copied and pasted take a chance on me, and where did you put that?
I just moved the console log down. It was up here.
This was earlier.
For the first one or the second one?
When I think it was from the second where it's still an X. You did.
So I just reran these tests.
Okay.
And what happened is we got our second one, which is great, but we lost our first one.
Okay.
So the only code I have changed is in this block.
Okay.
So I'm now going, all right, why did we lose the second one? So I'm going to go back. I'm going to copy and paste this back in. I'm actually just going to comment that one out and put this one above it. And now artist is in an array. Well, we don't want artists in an array. Why is that? Well, our first line is working great, but then we're coming back in here and we're going, oh no, we don't actually want the value. We want the value in an array. And so this line is just being completely overwritten. It might as well not be there. How do we fix that? If only there were a way.
Not for the array.
What's that?
We asked for the items, not the array.
Well, what we want to do is we want to say, if you're setting the artist value, go ahead and just put that in as the value. Else, if you're setting the tracks value, we need to work with arrays instead. So what we're going to do is we're going to put this in an if statement, and we're going to say if the prop coming in, and on this one the prop is artist, so we're going to say if prop is equal to artist, then set the value and fix our indentation. Else, if the prop is equal to tracks, then set it in an array. And so now our album, ABBA Gold, artist ABBA, it's in a string. And if I comment this one back in instead, we have our take a chance on me. All right, we're making progress. Let's run. Yep. So the reason that we did an else if, we don't actually need the else if here. We can make this like that, and we'll also still get it. The reason that you do an else if this is true, this will also, so this isn't a good example because prop will never be equal to artist and tracks. But basically, if you write, don't type this, just doing this as an example. If we said, let's say value is equal to 10. and we said, all right, we want if value is less than 20, do something. And then if value is less than 40, do something. So in this situation, it would run both this and this. But if we said, we only want it to run one of those two, we could go up here and say, okay, if value is less than 20, do this. Now this is never going to run because these two are chained. So it's going to go through and it's going to find the first if that is true or else if that is true. And once it is, it's not going to run anything else.
But then if you set value to 30, it would go to the second one.
If we set value to 30, exactly, it's going to run this one down here. So there are plenty of times that you want to do an else if. In this situation where we did prop and we set it equal, if we say if prop is artist, and if prop is tracks. So the reason why it's just marginally better to do an else if here is because if the prop is artist, we can tell the computer don't even bother checking to see if the property is tracks. We already took care of it for this one. So that's why it would be a little bit better to do an else if here, is because you're basically saying you already found the first one, don't even bother about the rest of the code here. And if we wanted to, we could do an else console.log something broke. And that would run if the property was something other than artist or track. All right, we good so far? No? Anyone else stuck? Okay. So we got our first check, we got our second check, great. Okay, so now let's keep going. If update artist runs on 2548 with artist blank, artist should not be set. Okay, so what they want us to do is to delete artist. So when we're in here with artist, if value comes in as an empty string, it's setting it right now as an empty string. So I'm going to copy and paste this, and I'm going to put it down here. And what it's saying is this artist is coming in as an empty string. They don't even want it in there at all. So what we're going to do is we're going to go into this if statement, and we're going to say, all right, if the property is artist, we're going to do another if. If the value is equal to an empty string, then do something. Otherwise, do something else. Anyone have an idea of what we're going to do if the value is empty? What's our objective?
Return empty.
Not return empty. We want to... It's not that we don't want to set it. It's that we want to... So artist 2548 is already set to Bon Jovi. So we don't want to just set this, we don't want to just get rid of that string. It's saying that artist shouldn't be set at all. So it wants this whole line deleted as opposed to the value.
So do we use delete?
We use delete. We are going to delete the collection at the specific ID with the property that they're passing in. Now, if we wanted to, instead of using the artist property, the prop value variable that's getting passed in, we could do .artist here if we wanted. We already know that the prop is artist. We just checked that if statement, so it's completely fine. And I would even argue that this is more readable code than using property, so there may be a little bit more value to this. So let's go ahead and run this. All right. 1 check mark, 2 check mark, 3 check marks. Hey, look, we got an extra check mark for free. Isn't that nice? All right, last check mark. No, not last check mark. Third to last check mark. All right. After we run update records on 2468, tracks free um, should have 1999 as the first element. All right, so let's copy this code. Let's bring it down here. Let's paste it in. All right, so album 1999, artist Prince, tracks free. Hey, that's right. Why isn't that working? All right, let's go back. Let's look at our data. And Prince already has an album called 1999, and we want to add in the track free. But what we're doing instead is deleting any tracks that are already on the album and putting free in its place. We don't want to do that. So there are a couple ways of doing this. The easiest way of doing it is saying, well, let's start with here. So we had this going on. So instead, how do we add something to an array? Push. So we are going to, let's just comment this out for now. Oh, and not open something weird. We're going to comment that out. And instead, we're just going to say, oh, well, it's an array, so we can just push it, right? So let's push in the value and run it. And you got the check mark. And we lost one as well. All right, well, let's figure out why we lost this one. So let's go back. Let's copy and paste this back in. We copy and paste that back in. And now what's happening is what it should be doing is giving me an error. So we're going up to 5439, right? Because we're in here and we're going, all right, go to 5439, go get the property called tracks. So we'll go up to 5439, go get the property called tracks. There isn't a property called tracks. So what we can do is a couple different things. The ES6 way, the latest and greatest way of doing it, would be, instead of pushing it, say, hey, go get the collection ID. Never mind, you can't do it that way. Change my mind. We're going to do it the good old-fashioned way. I'm curious. Yeah, no, we can't do it that way. All right, so what we're going to do is we have to check to see if tracks exists. So we're going to say if collection ID dot tracks. Okay, and before we even do that, we're going to, instead of writing the if statement, let's just see what comes out. We'll console log our collection ID tracks. And we will run it both on the one that doesn't have tracks and the one that does have tracks. And what comes out, we are trying to make this one work. And I was right. And we're trying to make this one work. Okay, and what comes out for the one that already exists is 1999 Little Red Corvette. And what comes out for the one that doesn't work, I'm going to take out that console log. Tracks is nothing because it doesn't exist, right? When we look up here, there's nothing in there. So what we can do is we can write an if statement that says if there is this, if you go to the collection and look at that ID, if tracks exists, then we want to salt and pepper it. Some people got it. That was good. Otherwise, we want to salt and pepper, push it.
Yeah.
Okay. Otherwise, we want to set it as a new array type. The other way of writing this, which might be a little bit clearer, is we can say if tracks is in the collection with that ID. Both of those should work. So let's run it. And first one, second one, third one, fourth one, fifth one. 2 more to go. Making progress. But I'm going to stop here and we're going to make sure you guys have every green check mark except the last 2. Anyone is stuck, raise their hand. Indentation super important, so don't forget to use Option Shift F because that's really going to help you line up. Oh, this is indented and this is indented, so we're only working with the artist here. And this is indented and this is indented, so it only applies to tracks. Anyone want a second set of eyes? There is, by the way, a curly brace all the way down here. Let me see if I can get that all on the screen.
I mean, I don't think this code
It's okay to ask for help.
Nope.
All right, congratulations. We celebrate objective hits.
Well, that's the reason I groaned was because I got one and then I lost another. I just missed brackets. I get very confused.
Once you start training your eye to use the indentation, they just fall into place.
Yeah.
And it's one of those things that you'll have someone screaming at you, use indentation, use indentation, use indentation, and you won't quite get it. And then as soon as you start training your eye to use the indentation, all the rest of the brackets get much easier.
Yeah.
Oh, see, that's a different way for me because I'm like OCD, so it needs to be like, there's this, and there's this. And you can speak what I'm doing. I'm like, okay, there's there, then there's there, so we're good.
So
Yeah, so it is arguable some companies will do this instead.
no, no.
So that's how I learned.
That's crazy.
And the reason I learned
Like so many lines.
the reason I learned that
I
way
can't
is,
remember right.
well, actually, it would be
Ah.
no, it would be like that. And the reasoning for that is because you know that this is the only line of code that's running with the else. And you know that everything in this if statement, this indentation is the same level as this indentation. And so because of that, it's much easier to read what's executing there. That is considered a more old school way of writing code. Um, the more modern way is to write it like that. Um, but I will say I did learn how to write code the way I just showed you instead of this way.
Oh, so then. Hmm.
All right, would you guys rather get help with this now or finish it out and then you guys can say a little late if you need help?
Well, wouldn't, in order to get the next one down, wouldn't you just put in the same,
So we're really close to the end.
you
So
would delete tracks?
let's power through. So here we're gonna say um, here 2548 tracks. We have to be careful about where we put this if statement though, because if we say we put it down right in here as an else if, it's gonna say, oh well, tracks already exists up there, so just push in an empty string. So we want to be careful and we want to put this up here
Before the first.
before the first if, because otherwise that first if is going to be true and it's going to execute instead of what we want. So in here we're going to say if value, if value is equal to empty string, then collection dot collection bracket ID dot tracks, and we're going to delete it. And we'll get our green check on that one and scroll up and make sure we didn't lose any others, because that's the whole frustrating thing on this exercise. And then the last one, 1245 album Riptide, album should be Riptide. So we have artists and tracks, but we don't have our something for album. So instead of doing a whole nother else if down here, we're going to get the tad bit fancy, and we're going to say else if property is artist or the property is equal to album. And we're going to run that, and we got it. And just to be super clear, we're going to change this back to prop.
Ooh.
All right, I'm going to put this down here. And that's everything. There's no scrolling. You guys 2 more minutes, and then I'm going to start coming around and cracking the whip.
string and then delete and all that, and it didn't work. And I was like, why isn't it working? I know that's the right thing to do. I was missing the else if. I had to put else underneath it. That's really annoying.
And I did the same thing, and like, cause I did it. I was like, you can't have else if. It was like, so,
You cannot have an else
so
if
I
without
had,
an if.
so I had an if, and then I had another if.
Yeah.
Because I didn't change the, when we put the one above it, I didn't change the if to an else, so it was like, no,
You can't do that.
not gonna work.
I can't tell you how many times I've gotten a cannot have else if without if. Where's the if? Oh, my brackets were off by one level, and you delete one bracket and the whole thing, and you're like, oh.
I don't know anything anymore.
You didn't teach last week, did you?
No.
That was Gus.
That was Gus. You got 3 more weeks of me after this. Not immediately next week, but you'll get me for another 3. Get me for Node.js and server-side stuff. And I will do my best to make connections so you guys see all of this front-end knowledge you can apply all on the back end. And we'll start drawing connections between SQL and Node and getting the back end working. And then that's, I believe, 2 weeks. And then I think you have me for another week on security, where we get to talk all about concepts and hashing. And don't ask me to talk about blockchain. That's not on the topic list. Do you want help?
No, I meant I heard blockchain and you're not gonna talk about Ether is my collector.
All right, green check mark. Green check mark.
Soon. No, I don't want help.
You do?
No,
No?
because then I won't. No, thank you though.
I'm creeping over here.
Oh, you are.
Want help?
Oh, I already got it.
Oh, good. All right, we're making progress. Got everything for the last one. At your line 32 and my line 32.
Doing this shit show on this today, I forgot that. Okay, why?
When did you type that?
It's like, I go to the bathroom for just a second. You can imagine. What are those things called?
The double horizontal lines,
Yeah.
or 4 lines.
Four lines?
Horizontal lines is what I would call them,
Oh, okay.
or bars. I also heard them called bars. It's like when I call it a curly brace and other people call it a squiggly brace. And I'm like, squiggly brace?
Right.
Squiggly.
That's fun. So I didn't type any of it when you were doing it.
Okay.
To watch you.
Okay.
But it allowed me to, after class, figure out what you were doing before you typed it.
That's a completely fine thing to do. So if you see something underlined, fix it. I think you guys made the right call on doing this one.
I'm still trying to catch up from when I was absent on Tuesday, so, but I am, let's see, I've made my way through, to this part right here.
Okay.
And I am understanding
Good.
wisdom, so I'm getting the extra steps and stuff, so.
Good.
Hope to be by tomorrow morning.
Yep, and I have the office hours tomorrow. If you have any questions during that, I'm happy to answer them then.
Thank you.
Yep.
Right. Like if you hold my hand, I know how to run. But by myself, I can't even walk.
I think I'm finally starting to get
By the time I get back to you, the answer better definitely be I love JavaScript.
What just happened? It went black and then came back.
Is your battery low?
Weird. I'm checking. No, 34. Did I hit a button?
The power button in the top right will do it, so maybe you went for delete
Yeah,
and
you're right.
that.
That's exactly what I did.
I did.
I've had my Mac like it died, and as soon as I plugged it back in, now it's right back where I left it.
Yeah.
So it doesn't always like. There's some reserve.
And it didn't. No, and you once one crashed on me for good, and it made this horn like squealing noise before it died forever. Still scarred.
Sounds great.
I missed all of iTunes and everything.
Okay, it is 8:30. You guys are not held captive here, but I am happy to help you guys through it until you get it, if you'd like.
Thank you, Mark.
Thank you.
Thank you.
Absolutely.
See you again.
Oh, and please submit something for each of the homeworks, just so I know where you guys are at. I have my handoff meeting with Jake, who is teaching next week, tomorrow evening. So if you guys can have your homework submitted by then, even if you don't have it all done, just to give me some feedback on where you're at. And if there's anything that you would like me to tell the next instructor, also feel free to include that in the feedback for tonight or Slack it to me directly.
Thank you.
And office hours tomorrow, 6:30, YouTube, submit questions on Slack.